Okay, everybody. Hello again. This is Harneet. I am the Director of Marketing at Preseem. Jacob from the Preseem team and myself will be coordinating today's webinar featuring Preseem and Splynx. Thanks to everyone who joined. We understand these are trying times across the world, so we really appreciate the fact that you can take some time out to join us for this webinar. Please check out some housekeeping rules I'm going to share before I introduce the panelists today. So obviously you see the chat option on the right. Please use this chat option to say hello. Let us know if you have any audio problems or something we need to know about so we can ensure a successful webinar. So please use the chat option. You will also see on your right panel a Q&A option, which is the questions and answers option. In this, you can type down any question at any point of time when you feel like it. We will take the questions at the end of the webinar, and Jacob will be taking the questions and we'll be asking it to our panelists. So nothing stops you from putting in a question when you feel like it, and we'll take care of the questions at the end. Now, this webinar is recorded, so as we promised, everybody who registered for this will get a copy of the webinar after we are done, and we'll record this and send out a video for everybody else. So thank you again for joining. Let's get this webinar started. I'm pretty sure this will be helpful, so I thank Alex from Splynx for joining us today. Hello, Alex. It's afternoon, I believe, in Spain.
Yes, 3 p.m.
3 p.m. Great. Okay, so let me quickly introduce Alex. I know a lot of you already know about him, but for everybody else who's joining and hearing about Splynx and Alex for the first time, just a quick reminder about who he is. He's the managing director at Splynx, which is the leading ISP framework and billing company in the world. Previously, Alex has worked as a network architect and attained several Cisco certifications in routing and switching, design, security, and SP areas. Alex is also a MikroTik and Ubiquiti official trainer. And at Splynx, he's responsible for sales, marketing, and business development. And I'm pretty sure a lot of you know him personally. So thank you again, Alex, for joining. Over to you now.
Thank you, Harneet. Okay, I prepared a few slides that I would like to show you. And the slides, here I will try to manage it a bit. Yes. So now I live in Spain, and we are for 3 weeks in staying at home. And the usage of the traffic inside internet providing network are growing. It's not growing that much as it's presented everywhere on the internet. So and Netflix and YouTube are reducing the quality of service. But I will show you examples, and I will show you some charts of the networks of my clients. So you will see how the traffic changed in Spain and Italy in these 3 or 4 weeks when we are all staying at home. And I have customers that are complaining that it's difficult to maintain their network now, and that they have many congestion points inside the networks, especially wireless links are suffering somewhere. And and we will try to understand how we can tackle this problem and how we can, with existing tools, how we can improve quality of service, let's say, inside the network of internet provider. And then we will see, and I will ask Gary to present us a nice and very awesome and super good solution, Preseem, that I really like, and I want you guys to see the solution and think about trying it and using in your networks. Okay, first of all, congestion or bottleneck. So as you know, in wireless world, when we work with internet providers that are building wireless networks, so access point-to-point networks, always if there is a high usage, many customers starting to download traffic, there is a congestion. So there is a decreasing of customer experience, and this is one of the points where we can find these congestions. But in general, there are like 3 areas where this can occur and where this can happen. Is first of all your uplink connection or exchanges where you are connected. If there are no enough ports, or if you have 1 gigabit port to your internet provider and rapidly traffic is growing now to 1.5 gigabit, so it's not enough and you need to upgrade to 10 gigabit port. Okay, so this is the first point where this problem can happen. And then, of course, the second point is backbone infrastructure, especially if you have wireless backbone links, license links, and these license links, they can run to certain megabit throughput, and then when you reach it, it's starting to decrease, losing the packets and decreasing the overall quality of service. And then the last mile, I mean, when you connect your customer to access point, or when you connect your customer to point, there is, if all other providers around you start also getting high bandwidth on their access points, so the usage of frequency band is increasing, and it's also leading to congestions. Okay, so what I would like you to show now is how traffic in general changed in Italy and in Spain during these 3 or 4 weeks. So these are the numbers, and I'll show you the chart of Italy Milano exchange, which was before, like 2 months ago, they had up to 0.9 terabit in peaks, and an average was around 0.75, and now it jumped to 1.1 terabit per second and 1 terabit average. So it's like 25% of overall growth. So here, I personally do not think that this is such a big growth like when I read it on the newspapers or the news, where they say, okay, Netflix need to immediately reduce all the traffic and do not provide this quality and change the quality, and YouTube as well. But here is the chart. So we can see that the usage or overall traffic in Italy in this exchange, it jumped. We can see the same picture in Spain, but it didn't jump like 2 times or 3 times. Okay, so it jumped, but I still think that these fiber networks are ready for this jump, and nothing will happen really. Another picture is from Telecom Italia. So this is the website. You can also find it. There is a link on that. And there is a website where you can track how changed the performance which is measured in pings. So this was the ping, for example, yellow ping was to Google, I think. No, to Google was the blue one, and it almost didn't change, because the local peerings, like in Italy, Google is in Italy as in any other country, and these local peerings almost were not affected. The red one was the peering to Amsterdam. So this peering from Italy to Amsterdam, I see that, yes, there were jumps. So probably some of the channels, some of the lines that are connecting, backbone lines that are connecting Italy with other Europe or with Amsterdam, they are suffering, okay, here. But this is really, I was also analyzing traffic in Czech Republic and Spain, and there was no that big difference between what was 2 months ago and what started now. So I mean, in general, traffic in exchange points and uplinks, I think it's not that big deal. The big deal will be the next, what we will see. So I will just show you also the example of Spain. It's very similar, 15% of overall growth in Madrid. And now all Spain is for 3 weeks. We are at home and we work from home. We watch Netflix and everything. And here you can see this is also, so you see that average also jumped a bit. So it's around 15-20% what was changed. And I don't think that it will grow. So, okay, so that's probably the maximum what we are using now. And probably all other countries that will turn to the same scenario, that all people will stay at home. So they'll probably see the same development. And this is the chart of my customer in Spain. So also you can see that this is the provider that has only one internet provider. And here you can see that before, like a few weeks ago, he had 1.5 gigabit of traffic, and now up to 2. Up to 2 was maximum, and now it's up to 2.5. Okay, but this customer, I was checking his Cloud Core router, MiCritic, what was changed, the usage was changed, but actually nothing changed there, because Cloud Core is working only as a BGP server. It doesn't have any other services on it, and they have many fiber network, many fiber customers. Let's say half, maybe 70% of their customers are on fiber, and also they haven't mentioned any decreasing of service. Okay, so you can see here that Cloud Core CPU usage was maybe increased just in 1-2%. Nothing changed really, and but they have also wireless network with MikroTik Ubiquiti APs, and in this part of the network, they are starting to feel some problems and decreasing of the service. Several customers called me during these days asking me, Alex, do you know how we can prevent torrents and peer-to-peer networks, point-to-point networks, peer-to-peer networks, how we can reduce amount of traffic in our network, how we can really recognize that this traffic is causing the problems, and how we can track it all. There are some tools in MikroTik that we can use, and I will talk about in the next slides. Okay, but this is actually the customers with wireless links, with wireless infrastructure. They are the customers who will be affected by this traffic growth. Okay, because traffic will not grow only in their networks, but also in networks of competitors, and the competitors that have also antennas on the same towers. So that will lead to decreasing of the service level. So that's what I just mentioned. Is in this scenario, in this customer that I have, then they have only one problem that can happen is when they have an GPON port, when they have many subscribers, then maybe these subscribers will utilize too much traffic that it will exceed 1 gigabit per port, but this will not happen in that scenario, because they have like every port is used for 50 max, 60 max, no more. Okay. But as I'm saying, the point-to-point wireless backbones can get congestions because they were, for example, they are designed and made for 500 megs, and now they will be used for 600, 700. Point-to-multipoint growth of traffic and point-to-point wireless links will be affected by growth of traffic in general. And yeah, because many people, as I said, many people are coming home and they do not only watch Netflix, but they started to use some torrents, some other things. They get some viruses, and now, as I'm saying, my customers were asking me about how we can control traffic more efficient way. And this is the reason why we are having this webinar. I think Preseem will show us how to do that. And existing quality of service rules that I was always using in my practice, it's centrally on MikroTik router. We were creating some quality of service rules, but it was quite limited because it was only setting priority for certain type of traffic regardless of the customers. So it was like, for example, if you have one router and where you connect 1,000 subscribers or 500 subscribers, you cannot say that under one subscriber profile, the traffic Netflix will be with a high priority. What you can do centrally on MikroTik, you can say, okay, I will make dedicated, for example, 100 megs for certain type of traffic. Okay, or I can mango DNS traffic and forward it first, or do not limit that. Okay, so it's in general, I can play a bit with traffic, but still it's not 100% efficient. MikroTik and the quality of service has own limitation rules. For example, we need to always, if you set up queues, the queue must be reached. So the limit of queue must be reached before some kind of priority is starting to be applied. Okay, these limitations, I don't like how MikroTik, or in general, I don't like central quality of service on MikroTik platform, and because it's not efficient. I was never able to configure it 100% correctly. Okay, maybe something like, let's give to certain type of traffic more dedicated bandwidth and on one router. Okay, this can be done. But if we are talking about per customer limit quality of service applying, so this doesn't work there. What I can do, of course, if I have MikroTik CPU, I can log into this MikroTik CPU of the customer, and I can play with rules inside this CPU and define the rules. And this is what I did in my practice. So when we were working and connecting customers with voice over IP and with certain services that we had to provide high quality, we were deploying MikroTik CPU, and on this MikroTik CPU, we created rules. So it means that per customer, so for example, customer had 10 megabit per second link, and under this 10 megabit per second, he had dedicated 1 meg for one service, 512 for voice, and that was working fine. Still, there is a problem of limitation of torrents and all this useless traffic, let's say, because MikroTik is not that smart to recognize the traffic. So it doesn't have deep packet inspection. It has layer 7 mark of traffic, which is not efficient always. And I was never able to define that this traffic is really peer-to-peer. So I found my routers were able to find some part of peer-to-peer traffic, but the other part of peer-to-peer traffic behaves very similar to other regular traffic, using the same ports as other services, and even layer 7 firewalls were not helping me. Okay, so this is still a challenge there. Ubiquiti Edge router, I just put it there because they have some kind of DPI, and I'm not a fan of Edge router at all. I don't like the performance of the platform, and I don't like how it's configured and how it's working, but they have some kind of DPI and quality of service, which actually doesn't work for me, never worked. And Edge router never worked for me at all. And when there's point-to-point links, they have some own quality of service, but this is what I say, it never worked. And also that's, I never found any solution that really helped me to build advanced quality of service. Okay, on the CPU level, we did it, and that was more or less efficient. It was working well. But centrally, to build something, never. And yeah, Preseem is the platform, and guys will describe how it works. What I want to say just from my side, that it has two main features that I found and I think that are very useful for every internet provider. Is first of all, it's unique traffic class recognition and quality of service queuing. So this is the first thing that they really do what MikroTik cannot do, and any other platform that I touched cannot do efficiently. And the second one is that TCP-based monitoring. So I was working with PRTG. Splynx has also monitoring, but it's always ping as SNMP. Ping and SNMP doesn't show you the real impact of congestion on your customer. Okay, the ping can jump or it can be still the same, but the TCP retransmits and the TCP window size. So this is really something what you can analyze and understand if traffic is going well to the customer and back, or there is something happening there. And Preseem has this feature, advanced monitoring, that helps to find you the bottlenecks, which access point is not working correctly, and everything is, the guys really did it an awesome way, in a graphical way, where you can see the towers that are suffering, the access points that are not working, and that everything is integrated with Splynx. So if you are using Splynx, you can install the Preseem demo, Preseem appliance, and it will grab all your customer list, and it will configure everything inside their platform. Okay, that's all from my side as an introduction to this webinar. Guys, please continue. Garrett.
Moving on to Preseem, as you mentioned. So let's hear from Gerrit about QoE, bandwidth management, and much more. Gerrit is a co-founder and CEO at Preseem. He currently leads our sales, business development, and all external client relationships. He has many years of engineering management experience, so he's not a salesperson. He's an engineer who turned into a salesperson, so he still has all his technical chops. And he has many years of engineering management experience, including managing an offshore development site in the Middle East. So over to Gerrit now to talk about QoE and Preseem. Thank you.
Yeah, thank you for the intro there, Harneet. And Alex, thank you as well. I think you did most of my job here already, so that's great. We're seeing a lot of the same sort of traffic patterns that have really changed over the last few weeks. The peak is not increased too badly, maybe 20% or so, but what we're really seeing is the off-peak has really gone up very substantially. So whereas it used to be, a few hours of really busy time, now it's almost the whole day, and that seems to be causing almost more problems than the extra load during the peak. So in this part of the webinar, I'm going to talk about quality of experience in Preseem, of course. I'm going to start with a bit of background on quality of experience, what it's all about, some examples of poor QoE. Then I'll introduce the quality of experience monitoring that Preseem does, as well as the optimization. And then we'll finish up with some very specific tips on, again, in these days with extra bandwidth load, what you can do about it, and then the integration with Splynx as well. And as Harneet mentioned, just type in the questions. We'll start answering those at the end of this part of the webinar. So let's start with a bit of a definition. What is quality of experience? Quality of experience is all about how your customers experience your service. And the main factors impacting it are bandwidth, are people getting their plan speed, latency without having to wait for packets, and packet loss. Now, bandwidth typically gets most of the attention here, but it turns out that latency is often much more important for a fast-filling internet. If you think about applications like gaming and VoIP and browsing and Facebook, they don't use a ton of bandwidth, but it's really important that the latency is very low. And what ends up happening, if your latency is too high, all those interactive applications that your customers interact with the whole time start feeling really, really slow. And in your customers' minds, they don't really know about latency. They just think about plan speed. So they immediately think, I'm not getting my full plan speed. Let me run a speed test. Maybe they're already running lots of other stuff in the background. The speed test results are poor, and then they call you for support. And in the meantime, if you are able to get a handle on latency instead and keep that nice and low, you'll find that you won't get most of those calls because it just feels way faster. And so if you think about, poor quality of experience really means slow feeling internet. The bits are flowing, the connection is up. It just doesn't feel very fast. Whenever you hear slow internet, think poor quality of experience. And so now the question is, the next part is we're now deployed in hundreds of networks worldwide. We've really focused on fixed wireless. We do have lots of hybrid networks as well, but certainly fixed wireless is the majority of our business. And the reason we focused on that is there's so much variability in fixed wireless. It's much harder to deliver a good experience on fixed wireless than it is on fiber, for example. And the main things that we found that can cause issues, the number one is actually shapers and plan enforcement. How you enforce your customers' plan speed, those packages, has a really massive impact on what happens to the user experience when they max that plan out. I'm going to talk more about that at the end of this slide deck on the optimization piece. And the next biggest problem is the last mile, your access points. Even under ideal conditions, you have to worry about different modulations and things like that. And the actual throughput you're going to see are probably not that close to what the actual spec sheet says. And then, of course, you have to worry about things like interference, line of sight issues, and all of that. And they can be, because of all that, there can be so much variability that really, on the monitoring side, we've put a lot of focus on the access point side here. And then, of course, you have in-home Wi-Fi to worry about. Now, you can't always do much about that right away, but it's handy if you can detect problems there. We see backhaul problems too, less often than the access points, but of course, if they happen, it's going to impact a swath of your network, so definitely jump on top of that. And then much less common yet, but higher impact again, if you're transit capacity, if you're out there, of course. And then also an honorable mention goes to overloaded microtics. We see this actually fairly regularly, especially if you're doing things like queuing in there. And if one of those cores starts maxing out, that can further impact your quality of experience as well. And the trick, of course, now is how do you figure this out? How can you determine where these problems are in the network? And Alex talked about this a bit as well, right? Most traditional network monitoring tools are based on ping and SNMP, and they give you a great idea about are your networks up or down, are the network elements up or down, but they don't actually tell you if they're delivering a good experience to your customers or not. And that's really the key thing to figure out here. And so one way to think about quality of experience issues in your network is there's simply bottlenecks in your network that make things feel slow, right? So a bottleneck could be a congested access point. It could be a Wi-Fi issue, backhaul, anything like that. And so the key is to find these bottlenecks, right? Because what these bottlenecks do is they have more data coming in than they can transmit. And when it happens, they're going to start buffering packets and eventually dropping those packets. So from a user experience perspective, this really hurts because they have less bandwidth at a higher latency and a higher packet loss. Now, the nice thing is your existing TCP traffic on your network actually has built-in mechanisms to detect this. So for example, If TCP detects that a packet is dropped, it sends a new one, it sends a retransmit. You can count these. And if the latency goes up, and this is usually what we first see in fixed wireless networks, you can measure that through something called TCP round trip time. Now, TCP round trip time is really neat. It doesn't inject any traffic. It's not like ping or ICMP. It simply tracks the existing traffic flowing through your network. So specifically, you need an inline device to do this. And what happens is the inline device can basically measure how long it takes for a packet to go from it through your network, through your backhauls, access points, CPE, through home Wi-Fi, right to the end user device, like a phone or a laptop or something. And then TCP on that device sends back an acknowledgement packet saying, yep, I got that. The ACM's traveling back. And when that gets back to the inline device, you can correlate those two and say that took 50 milliseconds, 100, 200, whatever. That's a latency sample. And you can just keep doing that. And so by doing this, you can see exactly what the end user experience is based on their actual traffic. And for those of you that do use ping, and I'm guessing most of you probably do, I'll give a couple of sort of examples of how they're different. So the first one is ping can't get into the home. So at the DMARC, it stops there. TCP, because it follows the round trip time, because it follows the TCP packet all the way to the end, it does the whole path. And the next one that we've seen a lot of is a lot of network elements tend to prioritize your ping packets over your customer's traffic. Handy when your gamers use ping themselves to see what happens because they get a nice low result. Not so handy to see if there's actual bottlenecks in your network. And then last but not least, again, round trip time doesn't inject any traffic. So you can do it on a much more granular basis, and it doesn't add extra load to your network or anything like that. So now I'll talk about Preseem a little bit. So Preseem, of course, it measures all those things I talked about, the round trip time, the retransmits, that's the whole monitoring part. And then we have dashboards to really show you specifically for your network, your access points, your backhauls, where the problem areas are. And so architecturally, Preseem basically consists of one or multiple inline devices. We have appliances, we can run on third-party hardware, and it really depends on your network topology. If you just have one link to the internet, you can have one box. If you have three, you can use 3 boxes. Each of those then connect to our cloud service where everything aggregates up and all the metrics come together. So there's only ever one place to check your network status and look at things. And then it's this cloud which integrates with Splynx as well. And its integration is really neat. I've got a slide at the end about that as well. But basically the idea is we want you to have all your information in Splynx, everything about your subscribers, your access points and network equipment, and Preseem simply follows suit. So Splynx knows that IP address 1234 is subscriber Joe, and Joe's in a 5x2 meg plan. Preseem just extracts all of that, and it makes it super easy to deploy. And I mentioned the access points as well. If you have your access points in Splynx, Preseem extracts all of those automatically. We connect to each one of those through SNMP, and the main reason we do that is to map out what subscribers are on what access point. And the reason this is so important, I mentioned before that by looking at things like round trip time, you can see if anyone subscriber is getting a good experience or not so good experience. But just by looking at that, you don't know why yet. But if you start comparing all the latencies for all the subscribers on a given access point, you can see right away what the patterns are. If all the subscribers have the same high latency pattern, you know the whole AP is having issues. If on the other hand, only 1 or 2 are high and most are low, you know your backhaul's okay, you know your access point's okay, it must be a problem specific to that subscriber. Typically in that case, you'll see it's either a signal strength issue, or if not that, almost always Wi-Fi in the home. And so by organizing this data in this way, you can really not only detect them, but pinpoint exactly where the bottlenecks are as well. And I'll show you a few screenshots now and give you a high-level overview. This isn't meant to be super detailed or anything. If you want to learn more, feel free to book a session with one of us, and we're happy to dig in more detail. But yeah, so this particular table is a list of all the access points. As I mentioned, it's a big focus for us because we see the number one. After the shapers, this is where we see the biggest problems. And what Preseem does, it figures out your peak periods every day for every access point based on a combination of throughput, number of active users, and then it marks them all, green, yellow, or red, based on those QE metrics. And then, so now you can very quickly tell every day which of your access points are struggling to deliver a good experience. And then we have more data to help you very quickly figure out, is that access point red because there's a few subscribers having issues? Is it overloaded? You've got too many subscribers on there, or is it underperforming? And you're going to take very different actions based on which one of those that is. So it's actually quite easy to give you some pretty good hints. And so I'll dig into one example a bit more here. This happens to be a Rocket an M5, Ubiquiti M5, and if you look at the bottom right chart, the downstream bitrate, that's simply a stacked bandwidth chart of all the subscribers on that sector. The numbers you see in the legend, each one of those is one subscriber, and those IDs will actually match exactly what's in Splynx as well. We use exactly the same numbers to keep that all sort of synchronized and easy. And if you look at that, it looks pretty reasonable. Some more data during the peak, a little bit less during the off peak, everything looks fine. But if you look at the top right charts, now you can see those latency, and that's the TCP round trip time latency I mentioned. And if you were to look at a ping chart here, you'd probably see 10, 20 milliseconds max because it gets prioritized higher. But what you can see here, and this is very common, is all the latencies are going up and down together. They're all moving in unison. And so that tells me right away the whole AP is having issues because during the peak, during the busier times, every single latency is elevated. It's not just one or two subs, it's the whole access point that's having problems. So, okay, we have an issue with the access point. What's it likely to be? Is it overloaded? Or maybe it's underperforming. Maybe there's an interference issue or something else that's holding it back. And it's really hard to tell that sometimes with some of this gear. And so one of the strong hints we can give you, if you look at the bottom left chart, there's that orange dotted line. So you see the same throughput overall for the sector. Because we're so focused on fixed wireless networks, we're now monitoring tens of thousands of access points worldwide. We have a really good idea of what a given model access point at a given channel width should be able to achieve under normal conditions. And we fed this information back into our app again. We also do reports on this, by the way, on our website. Twice a year, you can compare vendors, Ubiquiti, Cambi, and MikroTik, see how they all compare based on this data. But for the purposes of this, that orange dotted line, the bottom left chart, shows you what's typical. And so basically, if your latency is high and your throughput is well below the orange dotted line, you probably have an underperforming access point. Again, think interference, stuff like that. If on the other hand, you find that latency is high and like this example, you're at the orange line, chances are it's doing quite well. Compared to everything else that we see out there, it's at about the same level. This particular access point is simply overloaded. There are too many subscribers going through it. And so your options here are you can try and offload it. Perhaps you have the spectrum to increase the channel width on it. And if you can't do those things, you can also put a shaper at the whole access point level with Preseem. And I'll talk more about that a little bit later as well and how all of that works. The other big part that you can use this quality of experience data for is for your customer support team, the folks answering the phones. And really what you're trying to do here is to put yourself in your customer's shoes very quickly by understanding, are they actually having a quality issue? Is there some kind of bottleneck that's slowing them down? Or maybe they're just maxing out their plan speed all the time. And again, with the right kind of shaper, you'll get a lot fewer of those calls, but you might still get some. And so if you look at a little bit smaller charts here, but the rightmost chart in the middle with the green, yellow, and red on it, the white line there is the latency for that subscriber, and the black line there is the latency for that access point. And this chart actually tells you almost everything you need to know. Basically, if the white line is high, you know that subscriber's having a quality issue. There's some kind of bottleneck that's affecting the quality of experience, and that's why they're calling you. If the black line, which is the average sector latency, is also high, you know you've got a problem at the network. At least the whole access point is having issues. You need to go deal at that level. If the black line's low, you've got a subscriber-specific problem. Think signal strength, otherwise Wi-Fi in the home. If they're both low, they probably are maxing out the plan speed and need to upgrade instead. So it's really handy to see this data along with the usage and some other stuff that we track there as well, to really answer those calls very efficiently and have a much better idea of what is really going on with your customer's experience and the reason you're calling. Okay, so that was the monitoring part of Preseem. Next, talk a little bit about the shaping side and why this is such a big deal for the end user experience. So I'll start a little bit about why, if you think about very common shapers, so MikroTik simple cues, shapers built into the radios, they are designed to limit the traffic to a certain bandwidth, make sure your customers don't exceed their plan speeds. They do that very well. The problem is when they get there and the plan is maxed out, the experience can become very poor. And the reason for that is is that the simple shapers like that have one single shared queue, typically per household, per connection. And what happens is if something big like a Netflix comes along and maxes that connection out, that queue starts filling up the shaper queue. It becomes a bottleneck. It starts adding latency. You can see that. We can measure that with the round trip time on the left here. It goes right over 200 milliseconds. This happens to be a Cambium CP shaper, but they're all pretty similar. And the trick is that latency is added not just to Netflix, but because it is a shared queue, it is added to everything else in that same household as well. So now your streamers are hurting your gamers. And it is that latency being added that can cause those calls of my internet is slow when all they've done is maxed out their plan speed. Now, the good thing is this is actually a really solvable problem. And in particular, there's fairly new standards-based algorithms which solve this problem in a really simple and elegant way. And so in particular, Preseem uses a protocol called FQCoddle. You can Google it, and you can look at bufferbloat.net if you want to learn more about it. We've tweaked it a bit to make sure it is just right for fixed wireless networks, but fundamentally, this is what we use. And FQCoddle has two major improvements over things like simple queues. The first one is, rather than having a single shared queue for all the traffic, it looks at each flow or application individually. And the first thing that happens is every flow gets classified as either bulk or interactive based entirely on how much data is flowing through there. So with something big like a Netflix or a download or an upgrade or something like that, it'll be classified as bulk. If it's something small like gaming or VoIP or browsing, it'll be classified as interactive. And then what happens is the interactive traffic gets prioritized. So no matter how busy that link, you can always game, you can VoIP, your browsing loads really fast. It feels really snappy, keeps that latency really nice and low because nothing gets buffered at all for those interactive applications. And then for the big stuff, it creates a unique queue for every individual flow. And so now what happens is, first of all, because it's a unique queue per flow, they are separated from each other. So you no longer have the big applications, impacting each other. And the second big thing that happens is CODEL stands for controlled delay. It's a form of active queue management. And basically what that does is, rather than having this big buffer that has to fill up when a queue maxes out, it uses a latency target instead. And that latency target is both kept low and consistent. So now even when a shaper does kick in, which ultimately it has to, it does so with both a low latency and a low jitter because the latency is not so variable anymore. And so what this means for your customers is, even when they've maxed out their plan speed, it still feels really fast. What it means for you is, because there's no complicated rules, encryption doesn't matter. We don't do deep packet inspection. Deep packet inspection these days, because of encryption and the complexity to maintain it and all the new protocols that are coming out, it's becoming almost impossible to deploy. This is way simpler and more elegant than that, and solves this problem just by turning it on. So literally, we get the plan speeds from Splynx. We turn the shapers on based on that, and that's it. The customers will immediately feel the difference very substantially. And you'll find we hear this over and over again from our customers, that their support calls go down by half, 3/4 sometimes, just by making that one change. So yeah, really big impact on that. And so now I'll talk a little bit about, so again, with COVID-19, of course, increased loads on network. We've been doing everything we can to help our customers through this. This has been an unprecedented busy time for us as well, which is great. Of course, Big Gamer is trying to help. Really what we're finding is, as I mentioned before, the peak is going up a little bit. That certainly hurts. But a lot more traffic during the off-peak. So what used to be daytime usage that was lower is now much higher. And that bandwidth is kids watching Netflix, perhaps are doing e-learning, video conferencing. I've got 2 kids at home. They're going through that right now. Parents doing video conferencing. And all of that is happening at the same time. And so there's new protocols coming out all the time as well. So you really want something which can just handle that without having to learn about all those different protocols. That's what we love about FQCoddle. It just solves that problem. New protocol comes along, it doesn't even care. If it's video conferencing, yes, it will be bulk, but because the active queue management keeps the latency so low, it'll continue to feel fast. And even if your kids are watching Netflix, you can still have a really good conference call and keep doing that at the same time. So it makes a pretty big difference. The other thing we're seeing is an increased load on the access points. And I showed you that example before where you saw those higher latency samples. That's what happens, right, when they get overloaded. And so the idea here is you want to put a shaper at the access point. If you can't fix that problem fundamentally by increasing the spectrum or offloading some subscribers, a shaper is the next best thing, because what happens is FQCoddle gets applied at 2 levels. So let's say you put a 40 meg limit on an access point. It'll divvy up that bandwidth proportional to plan speed across all the subscribers. So they all get shaped down just a little bit to make room. And what that does is it makes sure the access point doesn't get overloaded, doesn't add a whole bunch of latency, and it prioritizes it much better than that and delivers a much better experience when that happens. So it's use some of the easy tools in the toolbox for us to really help you mitigate that. And we've heard quite a few of our customers say how big of a difference that made for them as well. Here I'll talk a little bit about the integration with Splynx and Preseem. This is a really short slide because it just works. This is so easy. Again, Splynx has your customer information, so subscriber names, their IP addresses, their plan speeds. Preseem extracts all of this automatically. As you update changes, make changes in Splynx from then on, Preseem just follows suit. So within a minute or so, a change in plan speed will take effect. So that's really easy. This really gives you one single point of data entry for both your subscriber information as well as network inventory. And again, the main thing we care about there is the access points. And Preseem uses the same names, the same name access point, the same names for subscriber IDs. And yeah, we do the shaping based on all that as well. So yeah, at this point, you can read this part yourself. Again, we've had a lot of, it's been super crazy busy for us the last few weeks. We've had a lot of our customers ask for help, so we've helped them configure things, tweak things, and it's really helped them manage their networks. If they found it, we keep hearing, "Thank God we have Preseem because it would have been a lot worse." This is a good example of that. And at this point, I'll hand it back to Harneet again. I'm assuming Harneet's around still. There we go.
For sharing your thoughts on QoE, bandwidth management, and much more. This is a great time for everybody to ask their questions. If you could please put your questions under the Q&A tab, it'll be great. We personally, I don't think we speak Spanish, but if anybody...
We lost Harneet there. He's clearly not using Preseem where he is right now. I'll turn my video off as well to try and minimize the amount of bandwidth going through.
I'm going to ask the questions quickly, and can everybody hear me? Yep. Hello?
Yes, I can hear you. We can hear you.
Okay, so good. I'm just going to quickly ask the questions in the Q&A tab. And let's start with the first question. So we already talked about it, but Gerrit, if you could please answer this question from Chris Tabbs. He's asking, in Preseem, recognize and prioritize speed test traffic?
Okay, so I'll give you the short and the long answer. The short answer is no. We don't do deep packet inspection. And again, because of things like encryption, forever changing protocols, and that kind of thing, it's really not that common to do it anymore. But the best way to think about this is think about the reasons your customers run the speed test. And I alluded to this earlier, right? If your latency is high, the internet starts feeling slow, web pages are slow to load, and your customers don't know the difference between latency and throughput. So they see what's a problem due to high latency, slow page load. They think it's a speed problem. They run a speed test. The speed test results aren't great, and then they call you. If you can keep that latency low, most of those calls aren't going to happen to begin with. And the way to do that is, again, the Preseem shapers with FQCoddle solve the problem of the maxed out connection. And if you can keep an eye on your network through the monitoring side, understand where the high latency has come from, almost all those calls are going to disappear to begin with.
Okay, thanks. There's another question about, will we send the presentation? We're actually recording the webinar, which has the presentation, and that's what we will be sending everybody. So you all will get this video once we are done, downloading it and editing it. So we'll send that video to all, so you can see the presentation there. Next question is from John. I think this is again for Get It. How will it know, I'm assuming Preseem know, which subscriber on which access point if CPE is in bridge mode with PPPoE?
Yeah, so that's a fairly typical deployment for us. Our integration engineers know a lot more about it than I do, but basically between SNMP access to the access points, the information that's available in Splynx, and sometimes if you're using, for example, a microtik to terminate your PPPoE sessions, there's an API there as well we can use. So between those, we can always put it together. This is what we do. It's just we've got a lot of different ways to figure this out.
Okay, I see a question here. Quick answer, please. Mitchell is asking, can this system be applied to fiber-based networks?
So absolutely it can. So again, a majority of our customer base is fixed wireless. Some of the turnkey tools we have, like mapping out subscribers to access points and things like that, and knowing what capacity to expect on a certain AP, is specific to fixed wireless. But we have a lot of customers with hybrid networks, and they tend to run their fiber traffic through Preseem as well, because the shaping works exactly the same way. You can still see you're less likely to have problems with the infrastructure on the fiber side, although it happens. But you want to know, are my customers having in-home Wi-Fi issues? And you can detect all of that in the monitoring as well. So our hybrid customers tell us to see a fair bit of value in that also. So the short answer is yes.
Okay, there's a quick question about the hardware. I already posted that. Preseem can run on off-the-shelf hardware or our appliances. There's more information available on preseem.com/hardware requirements. Please visit the website and you can get all your answers. We will be answering that individually as well. So I'm just trying to ask the questions which are more public. So question is from Justin K, and Justin's asking, we would like to try this, but based on the logistics challenges, does Preseem Splynx have this on a software base? Basically, what do we need to get this demoed on our network?
Yeah, so if you have Splynx already, really the main thing you need for Preseem is some kind of server that goes inline of your network that Preseem is installed on. And again, Preseem, there's two parts to it. There has to be an inline part because the shaping happens there and the metrics collection happens there also, but then all the metrics get logged to the cloud after that. So you need some kind of server. We have appliances, we have some distributors across the world we work with if you want to go that route, or if you want to use a third-party server that's supported as well. Basically, it runs Fedora. We ask you to install the operating system. We'll SSH and install Preseem. And our specs aren't crazy high, the performance specs, they are specific. And so what I'd suggest, if you'd like to give it a go, I'm sure Harneet will send out some emails after this as well, but just book a meeting with one of us and we'll be happy to review exactly what hardware you have that might work for you.
Okay, awesome. I think we have one more question, which is unique, and then we can ask that. And if anybody else has any questions, please type the question right now. This is a great opportunity. We'll be ending the webinar shortly, so please type in your questions. The one question I'm getting is from Vasilis K, and he's asking, do I need any major change in order to traffic shape on an access point level?
No, so once you've installed Preseem, again, you need an inline device running on there. We've integrated with Splynx, and we know your customers' plan speeds. To do a shaping on the access point level, you go into our UI, you find that access point that's red, and I didn't show it here, but there's a simple widget. You just type in the speed you want to shape the whole thing, and it takes effect. It's very simple to do that.
Okay, awesome. Yeah, so as Gerrit said, it's pretty simple to apply a traffic shaper on an access point level. One question which came in the chat, again, I'll recommend that you ask the questions in the Q&A tab. The question is from Francesco C, and he's asking about hardware. Can Preseem and the hardware become a single point of failure in our network?
Yeah, we get that question all the time as well. So it's always a good question to ask. So always when you think about deploying an inline device like Preseem, you want to think about failover strategies, right? That just makes sense. You never want one single point of failure. The most common way that is dealt with is set up two paths through your network. So if you use OSPF, you can do layer 3. sorry, for layer 3 use OSPF. If for layer 2, you can use rapid tree spanning protocol. But basically, you want to end up with a low-cost path through Preseem and a high-cost path around it. And that way, if anything goes wrong with that server, your traffic is still flowing. So that's the most common way we can deal with that. We do, if you can't do that, we have appliances available as well that have some optical bypass or electrical bypass built in also. But again, the most common is that low-cost, high-cost path.
Okay, there's a question from Hector P who's asking about burst limit. The question is not detailed, but I'm assuming he's talking about whether Preseem can do burst, and I think you can answer that question quickly.
Yeah, so we don't, but it's actually very much on purpose. Bursting was good a while ago. The main problem with bursting is it results in an inconsistent amount of bandwidth for your customers. Now, many applications don't care about that, but things like streaming video care a lot. And so if you start a streaming video with the burst on and it thinks it can get 10 meg and 10 seconds later it goes down to 5, you always get this little hiccup where either it has to buffer a little bit or change the resolution back down. So bursting can actually cause a worse experience than not having it. And with Preseem, because we automatically prioritize the interactive traffic and keep the latency down on the rest, you'll find that Preseem without bursting delivers a much better experience than a traditional simple-based shaper that does bursting.
Awesome. There was a question about Spanish and helping people with a guide in Spanish. I already replied that most of our business is conducted in English, but we do, we have customers who speak Spanish as their first language, and we worked with them, and we continue to work with them. We do have somebody in the team who can speak a little bit of Spanish in the support side, and hopefully that's helpful. But obviously, most of the business is conducted in English. We apologize for this, but Alex obviously can also help. So, for any of the Splynx customers who need some help with Spanish, we have Alex to help us out as well.
How is your Spanish, Alex? Since you live there.
Yeah, I'm here. I muted myself. Yeah. I think my Spanish is getting better every day, actually. And but I learned Spanish for 10 years. I started in my university, so it's not like that I came here and I started to speak Spanish. So I speak Spanish like for 5 years with my customers already, and here now when I live in Spain, I just have Spanish around me and I use it on a daily basis. So when I go, I do not go anywhere for the last 3 weeks, but okay, when I will leave, so I'll start speaking Spanish again.
My Spanish is terrible. I'll say that right now. For those in South Africa, I speak Dutch, but that's about it.
Yeah.
Okay, we got more questions. One question is pretty interesting, and it's been asked by Justin K. I'm noting that Preseem does not do DPI. Is it intelligent enough to pick chunk traffic and treat this separately, like Trojan, DDoS, etc.?
Not explicitly. You're right that we don't do DPI, so we don't get rid of that. We do shape it, of course, right? So if junk traffic comes in into Preseem, it has to shape it just like anything else. So on a per subscriber basis, it'll limit that down. But specifically, we're not a DDoS platform. There's different applications helping you with that. But yeah, it does mitigate it a fair bit through the shapers automatically.
Okay. I think we talked about the Splynx integration. We have time for only a couple of more questions. Please put your questions now. We can always reach out to you after the webinar. But for the live session, we just have 2 more minutes left. So the question is again about the Splynx integration. How is this integration? I think we answered that, but if you want to talk about the integration quickly again.
Yeah, I guess it starts with mentions about AP. So maybe you're asking about the access points. The main thing we'd like to see is to have your access points in the Splynx configuration, because then we can extract that list from there. It just makes it easier. We have different ways to get it, but if you have Splynx anyways, you might as well put it in there.
Okay. The question from Kesongo M is, can we work on QoE with a different simple queue with PCQ that is fixing in my network the issue of ping being disgraded when maxed out? I think we replace PCQ in that case.
Yeah, FQCardle would definitely replace PCQ. FQCardle, that doesn't exist in a MikroTik, so you need our inline device to do it. I'm not an expert on MikroTik, So I don't know if Alex has more things to say about the PCQ side or not.
Yeah. No, in general, here what you are saying is that, and there are other questions also in Spanish, that anything, so MikroTik is not used for queuing anymore. So if you set up Preseem, the MikroTik can be used for PPPoE termination, and all the queues will be just moved to the Preseem. So there is no. The PCQ is the most advanced method of queuing in MikroTik, but still it's quite far from to Preseem, so it's not not that intelligent.
Mm-hmm.
One question which I think I missed in the start was from Ben M, and Ben is asking, how do you audit bandwidth? Example, I use 500 TB per month and want to know how much goes to YouTube and Netflix.
Yeah, so we don't keep track of which application it is, but we do measure usage on a per subscriber basis. So you can see that in our dashboards.
Okay, I think the last question for today, not sure what it means, but Ben is again asking, does Preseem run on Proxmox environment?
Yeah, Proxmox is a virtualization software. We prefer not to. We do have some deployments in different virtual setups, but we found it adds a lot of complexity. And because it's an inline device, the performance requirements are far greater than running like management applications that don't need to worry about every single packet. So although it is in theory supported, we much prefer to go bare metal. It's just much simpler, way less chances of packet loss or delay, and it's generally the best way to go.
Okay, sounds good. I think with that, we are done with this webinar live part of that. So again, thank you everybody for joining us today. It was really great to have all of you join from all parts of the world. We appreciate that. Thank you, Alex. Thank you, Gerrit, for doing this for us. And we will be in touch with everybody who signed up, everybody who joined. If you have any more questions, you can always visit splynx.com and get your answers there. You can always visit preseem.com and get your answers about Preseem as well. We will reach out to everybody. We'll be in touch with via email. So if you have any more questions, please be in touch with us. Thank you so much for joining. Thank you, Jacob, for joining from Preseem as well. Thank you, everybody. Stay safe.
Thank you, guys.
Thanks, Harneet. Thanks, Alex.